Alrighty. Well, hey, good morning, everybody. Welcome to the Monterey Bay Aquarium and to Minorities in Shark Science YouTube channels. I'm right here in the middle. My name's Patrick. I work at the Monterey Bay Aquarium on the social media team, and we are so excited today to go shark watching with some shark scientists here with some of our webcams. So again, I'm Patrick here. Below me right here is the other better half of the social media team for the Monterey Bay Aquarium. That would be Emily. And then over here, the phone call, that is Curtis, our webcam guy. He's going to be flying us around here with the sharks. And then on either side, I'm flanked by some of the best minds in the biz over here to talk about sharks. We've got which side? We got Jada over here, Sophistication over on Twitter. We've got Amani over on this side at Curly Biologist. Good morning. Thanks so much for being here.
Hello.
Yeah, thanks for having us.
Yeah, this is awesome. So just very quickly to introduce yourselves, whoever feels like going first, Amani or Jada, let us know who you are and what your job is out there with the sharky Jossum world that you get to partake in.
Okay. Jada deserves to go first.
Sure. Okay. Hello, my name is Jada. I am now a graduate student at the University of Washington in the School of Aquatic and Fisheries Sciences. My research is going to focus on elasmobranch movement ecology, so like where these animals are going, what they're doing, what like why are they going to these different areas, and that kind of information is really important for conservation. So that's kind of why I want to focus on that. And yeah, and this is my attire, Sharky goodness, because we have to appreciate the sharks. I am going to take this off though because it's kind of a lot.
Okay, so you're literally saying stop the hammerhead time is basically what. Okay.
Yes, stop hammer time.
Yeah.
There's a lot of love coming in for that hat right now across the internet.
It was $20 at Target, so.
That's awesome.
Okay, I'll go. My name is Amani. I just graduated from Rutgers University with a bachelor's of marine science in May of this year. I am taking a gap year before I apply to graduate schools. I'm interested in elasmobranch physiology, conservation, and also functional morphology. And in my gap year, I'm working with the field school in Miami, assisting with their shark courses and future research that they have going on right now.
Awesome. Cool. Well, that's great. You've got all the qualifications necessary to guide us through this shark watching experience. We're so excited to learn all about sharks, all about your research and everything here. And if I can nail this transition here, we are going to begin some shark watching here with our shark cam. Actually, here, I'll show both of the cams that we have available to us here. We've got the open sea cam, which is showcasing our 1.2 million gallon exhibit that shows off the animals that you find in the Gulf of California and out to Hawaii. And then we also have the Monterey Bay Cam there that's going to show off some local species that we have here off of the coast of California and all up and down the coast. So we're going to get started right now with the shark cam that you folks may know out there. So here we go. There's that shark cam. This is showcasing the Monterey Bay Habitats exhibit, which is a 90-foot exhibit shaped sort of like a bow tie. And it's about 1/3 of a million gallons of cold water directly from the Monterey Bay. And here are some of our favorite Jossum sharky friends here. So we're going to be able to fly around this. So Curtis will be able to fly the cam, hopefully, to go see some of our sharks that we have in here. But first of all, maybe before we get started answering people's questions out there, Jada, Amani, can you tell us what is an elasmobranch? What is a shark? What are we looking for here in the exhibit for the folks who just might be crash landing and have no idea what a shark is? What are we looking for?
Okay, I'm going to take on the what is an elasmobranch. So elasmobranchs is a subclass of the class Chondrichthyes, the cartilaginous fishes. So you've got sharks, you got rays and stingrays, and you have skates. And sharks are a subset of the elasmobranchs. Imani, do you want to take that one?
Yeah, sure. I mean, sharks are basically just cartilaginous fishes. There's tons of them. There's over like 500 species. And their body is made entirely of cartilage, which is similar to what we have in our noses and our ears. So they don't actually have bones like we do. They are, cartilage is slightly flexible depending on the shark species and the hardness of it. Yeah, I mean, a shark is basically just a cartilaginous fish.
Whoa, and currently swimming right above you there, Amani, we just had a bat ray go by right above you. And also in the background was a 7-gill shark. So when we're talking about these cartilaginous fishes, also includes other organisms like skates and rays, right? When you're talking about that whole group like you were mentioning there, Jada.
There's another one.
There's another one, yeah. You want to tell us about the bat rays or the skates?
I feel like Jada's the one who can really go crazy with this, so take it away.
Okay, I mean, I love rays and skates. I've been working while I'm up here at Friday Harbor. I've been working on skate egg cases. I know you guys have the big skate in there, and I wanted to mention that their egg cases smell horrific, so bad. But I mean, it's a lot of fun to work with them, and I haven't worked with the animals themselves, but I have been able to see them, and we've had one hatch recently here. And they're so cute, and their egg cases are so crazy, and it doesn't make sense to me how that's what came out of an animal, but it is, and they're really cool to look at. So if you don't know what a skate egg case looks like, you should totally look it up. It is a really, really interesting thing, but I can't get enough of rays and skates. I think that they're just the cutest things ever. And yeah,
I've two questions for you. Can you describe that smell? And then the second question, I'm sure that some folks out there are wondering, is what is the difference between a skate and a ray, as Curtis is currently showing us a broad-nosed 7-gill shark swimming by there. But maybe first thing, tell us a little bit about how nose curling. And we got the bat ray swimming by right there. Tell us a little bit about the smell of that egg case, and then maybe tell us the difference between skates and rays.
Yeah, so the smell, I honestly think is indescribable. It's just like something is rotting. And we had people come up to the room that we were working in, and they were like, hey, I think like there's something dying in this room. And we're like, no, it's just these egg cases. I think there's like some kind of like sediment or mud or something in them that just, oh my gosh, it's so bad. I don't really know exactly why, but when we were working on them, I had to like leave the room to go take some deep breaths of fresh air, and then hold my breath and come back in, do some more measurements, and then go back outside. I may have been being like a little bit dramatic, but it was really, really bad. And yeah, so the difference between skates and rays is rays give live birth and skates lay eggs. And some rays don't have stingers, like the manta ray doesn't have a stinger, so it's not a stingray, it's a ray. And skates also don't have stingers, but they do have like these spiny ridges on their tails, and they have 2 dorsal fins rather than either 1 dorsal fin or no dorsal fins, and for rays. So it's a little hard to tell the difference sometimes, but if you look close enough, you'll be able to see a few differences there.
Gotcha. Thank you so much for that. I think we're going to go to Emily here to see what the audience wants to know, and we'll throw some questions over to you, Amani and Jada. But Emily, what are the folks curious about right now looking at the sharks? We also have a semi-cartilaginous fish in here that folks are probably asking about in the white sturgeon that's going out over there. But Emily, what did the folks want to know at this point?
We have so many great questions coming in right now. It's hard to know where to start, so I'm going to start at the beginning. We had a question a few minutes ago over on Twitch. How does a bat ray differ than, say, a pelagic stingray that we might have in our open sea exhibit, Pat? Yeah, so cool. Throwing that question out to Amani and Jada there. I don't know, Pat, if we might be able to spot the
I'll swap ray over to the open sea.
We got
cam
the bat ray up
quick.
on screen right now that Curtis is piloting perfectly.
We do, yeah. Anyone want to talk about bat rays and pelagic stingrays? I've got both cams up currently.
I'm gonna let Jada take the ray questions because she is far more of an expert on them than me.
Okay, I don't know like a ton about those specific rays. I used to be an intern at an aquarium, Odyssey Aquarium in Scottsdale, Arizona, and I worked a lot with like Atlantic stingrays, southern stingrays, cow nose rays. But bat rays have like this little pointed snoot, and they look a little bit like a cow nose ray, but with like a pointier nose. And the pelagic rays, I think I'm not exactly sure, because I know that there is a pelagic stingray, like a species, but then there are other species that we consider to be pelagic rays. And like, that's an important difference to know. I don't know. I can't explain what the pelagic stingray looks like because I can't remember. I'm not like a super expert.
No,
on
we'll hopefully get them up on the screen for you here in just a second. Yeah.
Okay. But yeah,
there it is. There, Curtis found it. You should see it in about 10 seconds there, Jada. But there's our pelagic stingray there going by in the open sea. Nice camera work there, Curtis. There's our pelagic stingray friend.
Oh,
you should
I don't know if I have that stream up.
You should be able to see it here in just a second. For those of you folks out there interested in, if you're looking for some homework to do, you can look up orca and pelagic stingray, because sometimes orcas will eat those. And if you are a shark fan, it's a pretty gruesome video to watch. But this orca did swim right by a diver that was next to a pelagic stingray. But yeah, we've got a couple of pelagic stingrays there in the open sea exhibit. Might be able to see it flapping by. But yeah, like you were mentioning there, Jada, very different face shape, very different lifestyle completely, where the bat ray digging with its face on the sand, pelagic stingray out there in the water column. We also have the hammerhead shark there in view right now, and we had your hammerhead shark hat a little bit earlier. I don't know if there's any audience requests for more hammerhead shark hat, but we've got both there in view.
Yeah, I also wanted to mention, I think it's really interesting that the pelagic ray kind of does like an oscillating motion with its, or I guess undulating motion with its pectoral fins, whereas the bat rays kind of do this like flapping motion. And there's a few different rays that do each kind of those motions. And I think that that's a really cool thing to notice, that they're so closely related, but they move so differently.
That's awesome. All right.
Yeah.
Emily, more questions.
There was a recent study done about the way that pelagic stingrays will kind of oscillate as they're swimming there, and how it helps them be more efficient swimmers in that pelagic world that they live in versus a lot of like the bat rays and stuff that do more of that flappy flap motion.
The technical term.
They're very technical scientific terms that we all know. Wonderful. Another great question that came in, why do we specify 7-gill shark? What's so special about having 7 gills, or do they have 7 gills? And then another question was, do we specify a number of gills for any other sharks?
I'll take this one on.
All right.
So the buntnose 7-gill is named after the fact that it has 7 gills on it. Most sharks have 5. Notice I said most, because to answer the second question, there is the 6-gill. Generally speaking, though, most of them have 5, and the 7-gill was named because it has 7 and it's a weirdo.
And can you tell us how many different types of sharks are there?
I think there's like over 500 different species at this point, and we discover a new one, something like every 3 weeks or something like that. It's
really
crazy. There's so many species of shark.
Wow. Okay. Well, so Curtis currently has the cam there on that broad nose 7-gill shark there going by. So you should see that on the stream here. What's the significance of just the one dorsal fin there on the back? Some folks might have noticed, Jada, you were mentioning the number of dorsal fins can be distinctive, and this one here, it just has the one. Anything particular there?
I'll go. So one of the distinctive features with sharks is the elongated body, which separates them from skates and rays, and then the dorsal fins. So some have 1, some have 2. And in the cow shark family, they actually have their dorsal fin way in the back, which you can see on this 7-gill. It's a lot farther back. Some sharks have it on top of their pectoral fin. Some have it between their pectoral fin and their pelvic fin, and one of those 7-gills have it in the way back. There's different reasons for this, and there's also different advantages. It varies on the shark, and it varies also on their lifestyle, how they feed, where they swim, what habitat they generally live in, and things like that.
Gotcha. And we just had a very sharky view there. We had the broad-nosed seven-gill shark, we had the bat ray, then the leopard sharks swimming by all at the same time. So lots of different sharks there in this particular exhibit. But maybe just a general question some folks out there might be wondering is how many sharks should there be in your ocean? I know it can be rather worrisome to folks coming to the coast thinking, oh, there's sharks out there. But more sharks, the merrier. Well, what's the general take for the shark science?
So I actually have a sticker on my water bottle that says you should be afraid if you're in the ocean and you don't see any sharks, because they are so important to their ecosystems. In a lot of specific ecosystems, they are apex predators. And when you lose that, the ecosystem kind of like goes wacky and out of balance, and it's not good. And I think people think that we are immune to the effects of losing sharks, but looking at how big the ocean is and how important sharks are to the ocean, that would definitely cause effects everywhere if we just lost all sharks. And I think it's really important to recognize that we shouldn't be letting fear get in the way of the respect that we should have for the animals, and recognize that they're not shark infested waters. They live there. That's like saying it's a human infested household. Like, it doesn't really make sense. You know what I mean? So I think it's super important to just, if you were to see a shark, just be calm, recognize that it's there, and I guess take in the fact that there's a shark in front of you. Like, that's a really cool experience, and they're super important. So I think we should be excited to see sharks and recognize that they're still in these areas.
Absolutely. That's awesome. Thank you. Emily, do we have more questions from the folks out there?
Yeah, absolutely. This is a really great question that we got. What is the purpose in a shark? What's the benefit of having a cartilaginous skeleton versus our hard ossified bones in our bodies?
It's a great question. Amani, Jada, you're being so polite to each
So
other.
polite.
We'll start.
Do you want to take that one, or you want me to take it?
You go ahead. I'll add on if you miss anything.
Okay. I think it's interesting to note, because this is something that I learned recently, actually, is that sharks and like their cartilaginous skeleton, that's not like the first fish like form. That's they decided, you know what, I don't need bone. I'm just gonna go with cartilage. Thanks anyway, evolution. So they just like got rid of it, which I think is really interesting. And honestly, I don't know if I really know a lot of the advantages. I know that it makes them super bendy, and if something is grabbing at their tail, they can turn around and grab right back if they need to. So I'm sure that's a pretty good advantage, but what other advantages can you think of?
I was thinking the same thing in terms of flexibility. Like baby lemon sharks, for example, can literally whip their entire head around and 360 it and like bite their own tail if they really decided that they wanted to.
What?
Yeah, no, they're incredibly flexible. Baby sharks in general are flexible. I think it just depends on the species in terms of how much flexibility they have. I don't know the exact answer to that, but the flexibility thing would be the biggest thing that I think is an advantage. Like if you're a bottom dwelling shark, like a nurse shark, you have to be able to push yourself up, off, and having the bendability of your spine a little bit is probably helpful. Most of that is done through their pec fins with the muscles that they have to push off the ground. But we are so non-flexible with our bones, and we can get hurt so easily because of that. For sharks, I think it's an advantage to have some sort of flexibility in there.
I also think it's interesting that they're so flexible. They can turn on a dime so much more easily than other like bony fish that you would see. Like they can just like flip and just turn so quickly. And that's probably really useful for hunting fish that are way faster than them. But yeah, flexibility has got to be huge for them. I wish that I was that flexible. That would be really cool to just not break my arm and just be able to do all these crazy things.
Yeah,
that'd be cool.
One of my favorite images in my head is when hammerheads are preying on something. They do all these crazy sharp turns, and you can see how flexible they are. And I'm sure that just lends further benefit to them when they're hunting, rays on the ground and trying to pin them down. Being able to twist and contort their body in all these different ways just adds an extra advantage to them. And at this point, sharks are just evolutionarily perfect.
That's awesome. That's a bold claim
Yes.
too, considering there are other fish in that exhibit right now. We don't want to let them know. Just like, oh, by the way,
Don't tell them I said that.
and we just heard Trooper there in the background, our stream pup.
Sorry.
No worries. Had a quick question here. Curtis was flying around and looking at a bat ray up close, and there are sometimes videos, and people will refer to bat rays and stingrays as alternatively sea pancakes, sea flat flaps, and things of that nature. But sometimes it looks like they're walking on the window with little legs there in the back, and then it kind of looks, some of the photos, it looks like they've got a little smiley face on the bottom of them. Can you give us a little bit of a walkthrough of the anatomy that we're looking at there with the bat ray, where it's got kind of like that face on the bottom and maybe looks like it's walking around? Can you tell us a little bit about what's going on there?
Yeah, so their faces are on the bottom of their body, and I think a lot of people think that like it's at the nose, but it's not. Like their mouth is on the bottom, on the ventral side. So that's really helpful because they do eat like crustaceans or other invertebrates that are on the bottom. So they have to dig for it, and then they can slurp it up from right here rather than having to, do a nosedive into the sand. So that's why they have their little happy face on the bottom. And when you see them, like, I guess walking, I see a lot of people mention that skates look like they're walking because they have these modified pelvic fins that are I can't remember if they're pelvic fins or anal fins, but they're a lot longer and they literally look like legs. So when they're scooting along the bottom, they use those to kind of propel themselves forward. And it's really, really funny. It looks like someone's laying down and just trying to like wiggle their way forward. And yeah, so that's why skates look like they're walking. But I know that stingrays will go up on the wall and kind of like flap against the wall too. I'm not exactly sure what that behavior is, but it's also interesting. Yeah. They don't have those modified fins the same way that skates do, but they can do that spy hopping, flapping motion as well.
Well, yeah, for the folks who have maybe visited the aquarium in our bat ray touch pool. And I just realized, Emily, that in this scene, I'm completely covering your face up with the shark cam. I hope that's okay.
I forgive you.
Okay,
yeah.
Thank you. At the bat ray touch pool, we do have the bat rays go by and splash the people that go by every so often. And my understanding from the aquarist is that when they're slapping the walls there, that's a potential feeding mechanism that they'd be using in the wild along the banks of the slough, kind of slapping and maybe knocking some crabs in. But I think in this particular instance, they're just trying to get closer to the cam because they want to be featured during this live stream with you talking. I think that's the scientific explanation there.
They want to be a star.
Exactly.
Yes. Give them all the paparazzi.
Yeah. They're ready for their Finteen moments of fame.
The paparazzi.
Yes.
Okay. All right.
Paparazzi.
Paparazzi. Yeah. Okay. Yeah. Well, we're getting off track there. Emily, can you tell us what some questions might be that we have here for the shark folk?
Yeah, we've got just so many great questions coming in from all over the place. This one, we might need a little bit of Curtis's expert piloting over on that Monterey Bay Habitats cam or shark cam there to see if we can spot one of those broad-nosed seven-gill sharks. Folks are curious, do we have males, females, both? How can we tell? So this is a lot of fun, and I love talking about this with our guests. Amani and Jasmine, do you want to talk about how we can tell males and females apart?
Yeah. Do you want to take this one?
Sure, I'll start and you can finish. So male sharks have claspers, which is just a shark sex organ, basically. And when they mate, they have two on the bottom. And they actually cross over when they mate. So if this is the bottom, these are the two claspers. If the female's on this side, they cross over like this. It's a hard cartilaginous organ. And it goes into the female. I can never say this word correctly. Cloaca.
Yeah.
Yeah.
Word of the day. Ding, ding, ding.
Yeah, exactly. That's where it goes into the female. And shark mating is actually pretty rough. You can look up videos of it. The male shark will often be like biting one of the pectoral fins of the female to kind of like hold themselves together. It's not graceful like whale mating where one whale's like holding them both up and it looks pretty and beautiful. It kind of just looks like a fight in the ocean. But the female actually has tougher skin than male sharks as an added protective mechanism for mating, because oftentimes when you look at females after mating, they have scratches all over their body from biting. And so their skin is actually thicker to make it so that they can be safer and not get injured during mating.
So not like literally, not just a metaphor, generally that females have the thicker skin between the two. Okay. Sorry, that was a terrible joke.
And yeah, so they do have thicker skin, and typically, I guess not in all species, but in some species, the females are bigger. So in that song, Baby Shark, you go Mommy Shark and then Daddy Shark. I'm like, that's inaccurate for a lot of shark species. And I have to be that biology person that's like, oh, well, this is a little inaccurate.
No,
but it's fine.
no.
So
Thank you so much for bringing that up.
Yeah.
No, because we have numerous issues with the Baby Shark song, just generally the main one being tagged into every single discussion around that particular song when it was going around. And I do want to appreciate the restraint that everyone showed, Amani, when you said Baby Shark earlier, that it wasn't just do all in the comments section there. But yeah, to that point, that is something that folks may be wondering a little bit about, is like, why generally are some of the, like, for example, like a great white shark, why is the female so much bigger than the males tend to be? And that has it's pretty cool stuff to find out, like, why those big mamas are out there.
Yeah, I mean, you got to fit all kinds of babies in your body, and it takes so much energy to do that. So you're gonna, in a lot of cases, need a bigger organism to do that. And since the males don't have to put in that energy, they don't necessarily need that much space to create the babies. Like they just don't need that space. So in a lot of species, the females are bigger because they have to be able to hold the babies.
Right. So what you're saying is that great whites give birth to live young. That might be something folks out there don't know. Can you tell us a little bit about shark reproduction generally? Because you talked about egg cases and different things. Like, how are they making those shark babies?
Yeah. So a lot of sharks actually give live birth, but some sharks actually lay eggs. So there's a bunch of different modes of reproduction within the shark group. So like horn sharks lay eggs, but great white sharks and thresher sharks and mako sharks and a lot of other species give live birth. And it is totally dependent on species. But yeah, there's a few different modes of reproduction, which when I learned that, I thought that was just the coolest thing. Because usually in one specific group of animals, you have one mode of reproduction and that's it. But sharks are like, no, we want all of it.
All of it. All
like,
of the above.
3 modes of reproduction, just so we can make sure there's a lot of us.
I'm also noticing, just very quickly for all of us, is that looks like we have a diver coming into the exhibit, potentially to do some feeding, some maintenance here. So we'll get to see temporary marine mammals entering into the Monterey Bay Habitats exhibit here. Looks like there's going to be some giant sea bass training. That's going to be a lot of fun there. So that'll be happening in the Shark Cam. So Emily, can you give us some questions here from the folks, and then maybe we'll head over to the open sea cam just for a quick sec while the divers get set up.
Yeah, Jada, I think that this one might be a great question for you. We had a 9-year-old young boy over on Facebook wondering, why are stingrays flat?
That's a really good question. I don't think that I know the answer to that. I know they eat at like a benthic. They're not all exclusively benthic, obviously, but they tend to eat in a benthic environment. And I think that it's helpful to be that shape so that they can kind of create like a suction to pull food into their mouth. But that's my hypothesis. I'm not exactly sure I know the answer to that question, but it's a really good question, and now I really want to look into it.
Yeah, I think we have a new proposal for next grant studying. Yeah. Wait a second, why are they flat? Maybe they will grow up to be the scientist one day to find that answer, or you will. That's awesome. We also had some questions, and Pat, I noticed that you just pulled up the open sea cam, which good transition. You read my mind there. We had folks, and this is probably one of the most common questions that we get at the aquarium. Whenever people see sharks, the first thing that comes to their mind is Jaws. They think of these big sharks attacking people. And so we have a lot of questions from folks tuning in right now wondering, are these sharks that we're looking at aggressive? And is it safe for those divers to be in the water with them right now?
I'll go ahead.
Okay.
So in terms of aggressiveness, it varies by species. Some sharks are a lot more curious than others. Generally speaking, sharks don't want anything to do with us at all. Like you guys have leopard sharks in your aquarium. Leopard sharks are skittish. They just want to go away. You don't really see them when you're diving because they don't want to be near you. Blunt-nosed seven gills potentially could be more of a curious / aggressive species. I don't have any personal experiences with them, but it's definitely safe for the divers. It's definitely safe for you to go in the ocean and dive. It's safe to go swim with sharks. The main thing is you have to respect them. Similar to the way you'd respect a lion, you would not walk up to a lion and pet it out in the open. You would give it its space. And the same thing applies to sharks. They're not man-eating. A lot of times when people get bitten, it's because they were either not handling the shark correctly if they're like recreationally fishing, or they step on them, which like I would want to bite you if you stepped on me as well. But in general, they're not, these divers are perfectly fine being in the aquarium tank. You're fine being in the ocean. You're not at a huge risk of being bitten or attacked by a shark.
Yeah. I just want to add, since I also have some experience as an aquarist in an aquarium, I've gotten that question a lot, or like, how do they not eat the other fish? And like, they're fed so well in an aquarium that they're not always hungry enough to just go after the other fish in the exhibit. And you have to think about in the wild, like their success rate of actually getting prey isn't quite as high as they would hope it to be. So they're getting fed really well. They have no reason to go after the divers that are in there. And like Amani said, like you can go into the ocean and be around sharks and be perfectly fine. You just have to remember that they're wild animals and respect them from a distance and just admire them from a distance. Because if you were to get too close or provoke them in any way, they might get scared and then go into a defense mode. And that's the reason why some people get attacked, is because they're provoking the animal and, like Amani said, not handling it correctly or things like that. So recognize that it's a wild animal and wild animals are going to do what wild animals do, but it's not necessarily unsafe. And I think it's a really interesting thing that we're so afraid of them when they on average kill about 4 people every year, but we kill about 100 million of them every year. So completely different number. And honestly, they should be way more afraid of us than we are of them. But I just think it's really important to recognize that that's where they live. This is where they belong. And we just have to be like, oh, cool. Enjoy your space. I think you're beautiful. And I will stay over here.
Absolutely. And that notification that just went over is exactly that's the ding of reason right there that just went off. Absolutely 100% agreed with all of that. I did just want to offer, and I figured out a way of not covering you up there, Emily. So you're now no longer covered by the cam. But yeah, I've actually gone diving in this Monterey Bay Habitats exhibit with those 7-gill sharks a lot to clean the windows. And it's really interesting because the 7-gill sharks are actually very apprehensive of you. And I had an experience once where there's a diver elevator that you may have seen with the divers going in, and you're supposed to lower the elevator when there's no sharks around so that they don't, run into it or anything. And so we were lowering the elevator, and then somebody dropped something. So we went back down, came back up, and then didn't really check to see where the sharks were again. And so as we kept lowering it, I looked over, and then right next to me was a 7-gill shark that was swimming along peacefully, and then came up to a realization that it was between the wall, the elevator, and me. And I looked at it, and it looked at me, and its eye, I feel like it got really big. It was just like, oh no, I'm stuck. And I was like, oh no, you're stuck. And so I ended up pushing myself underwater, and the 7-gill shark swam right over, just like, oh, thank you. So the 7-gill sharks in there, definitely, they look at you just like, please don't blow your bubbles on me, and then keep swimming by. So definitely a very different experience swimming with those sharks than folks tend to think just from when you've seen the media. Anyway, that's my seven gill shark story where I bonded with one. We both had a mutual fear at the same time. All right, Emily, what kind of questions do the folks have out there?
Yeah, I think that Jada, you actually set this one up very nicely for us. Folks are curious, what kind of conservation issues are there surrounding sharks, and what is being done to protect them? So Jada and Amani, if you want to tackle that one.
You want to take this one, Amani?
Yeah, sure. I'll start. So in terms of shark conservation, there's a ton of different issues with conserving them. We have a tendency to focus on, as the public, what we hear most about is like shark finning and overfishing. But in general, there's plenty more issues in sharks, like bycatch, which is when you're fishing for another thing and you happen to end up with sharks in your net when you're fishing, and they die, and that's considered bycatch. So conserving them, I mean, there's a ton of different ways that you can go about conserving them. There's always new studies about what's a better way to conserve them, what can we do as people to conserve them. We have, different laws about how many you can take out, which species you can take out, which ones are incredibly endangered, things like that. And I mean, on top of that, we just have general shark trade things. When you talk about shark finning, a lot of times people focus on Asian countries. And the thing that you have to recognize is that, yes, they might be eating them, but a ton of Western countries are trading the sharks. A ton of Western countries are contributing to catching the sharks and then relocating them to different countries. And so we can't solely blame certain places that eat them and say it's your fault that sharks are dying when we're contributing all the time by fishing for them as well.
Absolutely. Jada, did you have more you want to add?
Can you repeat the question one more time?
Shark conservation generally. What do you think is important for folks to know out there about conserving sharks?
Yeah, I think Amani pretty much covered it. It's just like it's not one specific country or one specific area that is killing all the sharks. Like we in this country, like the West, the East, everywhere, we're all kind of part of the problem, whether it's bycatch or targeted fisheries. Like we should just, there's a way to do sustainable shark fisheries, because there's a way to do sustainable fisheries for pretty much every fish in the ocean. So it's just about doing the work to make sure that we're being sustainable rather than just catching all of them. And also trying to minimize the bycatch that we have from other fisheries. It's just a matter of trying to be better and finding out ways to be better.
And speaking of your open sea exhibit, you guys have scalloped hammerheads, and scalloped hammerheads are often bycatch because they have a tendency to travel in schools, and they also have a tendency to be around tuna, which is a huge fishery. And when you're fishing for one species, it's really hard to just put your hooks in the water and then say, this is only for this one. No one else can have this hook. Like, you can't just tell sharks to stay away from it. And so, for scalloped hammerheads, a lot of times they can end up being bycatch, because they will be around other species that we fish a ton.
Gotcha. Yeah, no, absolutely, with everything that you're saying there. And just a plug for the Seafood Watch program. If you folks out there are looking for ways to know what kind of sustainable seafood exists out there, and if you're not familiar with the term sustainable, great look of a hammerhead shark just there from Curtis. Sustainable means that we can have our fish and eat them too, that they're here for now and for the next generation, and that they're well managed. And so, you can have fisheries where there's plenty of that seafood that you're going after, but it's very destructive to other habitats out there that other animals rely on. Or you can have fisheries where the animal that you're going after is not doing too hot itself. So lots of different things related to what you were all mentioning with bycatch and things like that. And then also something that we know intimately at the aquarium is that seafood is one of the most globalized commodities on the planet. So where you're eating your seafood, you might come to Monterey and you order a seafood dinner, and that seafood may not have actually come from Monterey at all. It may have come from the other side of the ocean. Some things that folks may not know is that often things are caught in one place, shipped across the ocean, processed, and then shipped back over. Cannery Row no longer has any canneries on it. And so where are the canned and processing foods happening? oftentimes other places. So really important what you're mentioning there about that sustainable seafood, and especially as you were mentioning, Jada and Amani at the beginning, sharks are an integral part of the ecosystem, and so we need to look at ourselves and how that whole world is connected with its seafood there to make sure that there's plenty of sharks so that we can have those healthy oceans that we depend on. All right, I think it's time to go to Emily for some more audience questions here. Emily, what do the folks want to know?
We'll go with something lighter here. Shark skin. It's covered in tiny teeth.
Yeah.
Let's talk about that.
Oh my God. Hold on. Let's get that.
I
There's
can see
that
Amani's reaction. Yeah.
Oh my gosh, let's talk shark skin for the rest of the time. Okay. Can I nerd out about this, Jada? And then if I miss something, you can tag in. Okay. So shark scales are modified teeth. It's a type of placoid scale. It's called dermal denticle. Is the super sciencey term for it. And basically it covers the entire body of the shark. And the individual denticles are covered in a hard enamel, kind of like our teeth, which makes them incredibly tough. And a lot of times people will say that sharks feel like sandpaper, which is true. So if you are touching a shark and you go from head to tail, they feel super smooth. And if you go from tail to head, they feel really rough. And the roughness actually changes depending on the species because dermal denticles are not all shaped the same. There's an incredible diversity of what dermal denticles look like. And I encourage all of you to just spend a day looking it up because it's so cool. They have a ton of different advantages in having dermal denticles. The main ones are that and turbulence. So the way that the water flows over the dermal denticles actually is what helps the sharks move so smoothly and gracefully through the water and not experience drag. And I mean, I could talk about this all day. I think the coolest thing to me is the fact that they're modified teeth. Sharks literally just have teeth for skin, and that's awesome.
That's so cool. So where do you find the giant toothbrushes for your sharks to brush the whole being? Okay, perfect. Yeah, you do need a wholesale size toothbrush at that point. Yeah.
I'm pretty sure that whale sharks also have them on their eyeballs.
Yes, that was a study that just came out. Yeah.
No. What?
Is that the weirdest thing ever?
Yeah, they actually have like a small layer, don't they?
Yeah, you have a layer of teeth on your eyeballs. Like that's so gross, but also really cool.
Oh my goodness.
Yeah, it's my favorite whale shark fact.
So we need to get that paper ASAP here. I wanna read that and see what's going on with it. Oh my goodness. Sorry, I'm pretty floored by that. I'm also trying to come up with a pun at the same time. I'm also trying to produce the show, so I'm sorry everybody if I let you down there. By like the skin teeth of your eyes. No, there's something there. There's like by the skin of your teeth. By the skin of your eyes. There's some. Sorry, I'm done. Emily, question from the folks out there.
I'll save you, Pat. No, okay. I am also very distracted by eyeball teeth. But we did have a question about the hammerhead. Pardon me. The hammerhead sharks. Another really popular question we get: why the hammerhead shape?
Ooh, okay. Sorry.
I can always tell which one of you is going to answer because of the.
I love this question.
I love it.
Because I actually wrote a grant on trying to figure out why there are so many different hammerhead species and why they're shaped so differently. So you have like the bonnet head that looks like a little shovel and they're pretty small. And then you have the scalloped hammerhead and you have the wing head and you have the scoop head, and they all look totally different. There's so many species. And they all look totally different. And I was trying to figure out, I guess, what is the difference and what are the different advantages between these different like varying shapes of cephalofoil. And I didn't actually get to do the research for it. This was just a grant that I was writing. But it's something that I'm interested in, and it's a really cool question. So I know that there has to be an advantage for the different shapes, otherwise they would not have evolved. So I don't know what the advantages are, and I don't think science in general knows what all of the advantages are, but there's definitely information out there. I know that their sense of smell is different from like a little bit different than normal sharks because it's set on two completely different ends of its head and they're so far apart. And same with their field of vision is just a little bit different. And there's all these tiny things that you might not think about that are different because their head is shaped so weird.
That's awesome.
Their heads are super cool. I'm gonna go off of this and talk about Electro Reception really quick.
Yes.
So sharks have a sixth sense, which basically allows them to sense electromagnetic fields around them. And they are detected on their hue by this thing called ampullae of Lorenzini, which is a mouthful. If you look up pictures of the head of any shark, you see these little black dots. And those are the ampullae of Lorenzini. And basically with hammerheads, what it does is they have more area to sense this. And hammerheads eat rays. They eat a lot of bottom-dwelling animals. And they use their cephalofoil to basically pin the rays down. And so the benefit of having a head that's that long is they get like accurate readings on where this animal is that they want to eat.
Oh, that's so cool.
Yeah. I just wanted to talk a little bit for a second about how they pin these rays down. So they have like their weird head that goes this way. And the great hammerhead, I know for a fact the great hammerhead eats rays. I'm sure that other species do as well, but the specific behavior that I'm talking about, I know that it has been observed in great hammerheads. So they have their head and they will go up to a ray and like pin it down sideways and then they'll flip and turn and chomp the pectoral fin so that the ray can't move and then it's just dying and they've got an easy meal. And I just think that is so wild that they're like, you know what I'm going to do? I'm going to use my head quite literally. Yeah. And then they did. It's really cool.
And on top of that, they're super dedicated to eating the rays because hammerheads have been known to have the barbs of rays sticking in their mouths. And they'll just keep eating them. They're like, this is my favorite snack. I don't care if it hurts. I'm going to eat it.
What?
Yeah,
that's me with chips that are way too hot. It hurts, but it's so good. You just can't stop.
Like it hurts, but I love it.
So do you think when the hammerhead pins the ray and is able to like bite onto it, it just goes nailed it every time? And then the ray is actively trying to nail the shark? Sorry, I just had to get a few hammer puns in there.
Speaking of, okay, we're going to talk more about this hammerhead family really quick because speaking of feeding, one of my favorite hammerhead facts is that the bonnet heads actually eat seagrass and can get nutrition from the seagrass. So they'll eat crabs. When you dissect them, you can take bits of crab out of them. And there was a paper written by a PhD student that came out a couple years ago that showed that they eat seagrass. Like they eat a salad with their meat for dinner. And they actually get nutrition out of it, which is crazy because they're the only shark that we know of that does that.
They're literally eating surf and turf right there.
Yes. Yes. One known omnivorous shark species, and that is so cool. And it is one of the cutest sharks, I might argue, and they always look surprised. They're so cute.
They're so cute.
I had no idea about omnivorous sharks, like at all. That's
the
crazy.
One.
Just the one.
So do you think that they take a little bit of squalene and then ask a lemon shark for some help for some vinaigrette on the no? Sorry.
Bonnet heads are definitely food snobs, and they just want the most high quality dinner.
That's so great. Yes.
Sorry.
No.
Can I also bring up another weird thing about some sharks that people don't know?
Please. Yes. The floor is yours.
There are endothermic sharks to an extent. Ooh. So I think that this is really, really cool. I know that the thresher shark basically just kind of warms like its brain and its eyeballs. However, the salmon shark can raise its body temperature. I believe it's like 60 degrees Fahrenheit above the ambient water temperature because it lives in the Arctic and it needs to chase down prey that is fast. Whoa. So it has like this core that it's like a countercurrent heat exchange system so that its blood is constantly getting warm and it can warm up like its most important muscles and its brain so that it can function at like this super high level in really cold. Because you know how like when your hands get really cold, you can't move them that fast. you would imagine that would happen with sharks as well. So since they live in the Arctic, they're like, no, man, I'm not dealing with this cold. I will get warm. And then they can. And I think that is one of the coolest abilities ever. And salmon sharks are not talked about enough, and they deserve some more recognition.
Absolutely. In fact, we recently had some folks send in some video of a very small white shark that was swimming around very close to shore here in Monterey Bay, and it actually turned out to be a salmon shark that we had here locally, just like basically right in the intertidal zone. It was chasing after a few things there. So salmon sharks, definitely look those up for you folks out there tabbing over. They look like a mini great white, but super cool.
They're so cute.
Yeah,
that's so
They're
awesome.
so cool. Jada dropped that term, countercurrent heat exchange. I'm going to explain it really quick for the people.
Yes, please. I'm sorry. I forget to explain it.
So basically, if you have to put this really simply, if you have two veins, one where blood flows from this to this, and the tail is over here and the head's here, you have warm blood going in and you have cold blood here. And so as the cold blood moves past the warm blood, there's heat exchange and it reheats it to move through the body of the animal again. So basically, instead of having one side that's warm, one side that's always cold, they have some cold that then is reheated as the warm blood is flowing.
Very cool.
And fish also do this with oxygen to make sure that their blood has as much oxygen content as it possibly can. So they do the same countercurrent thing, because if they were going in the same direction, you only get to about, like, each would be about 50%. And then like that, you're maxing it out. But if you keep going this way and blood keeps coming and blood keeps coming, you're going to be able to maximize your heat exchange or your oxygen exchange, which is really, really interesting.
Absolutely.
Yeah.
And that's actually, I don't know, Emily, if you were about to bring this up, but that's actually how we heat the water in the open sea exhibit that you're looking at right here, is with some countercurrent heat exchange, right, Emily?
Yeah, and usually works much better when we have humans inside of the aquarium, because our nice warm bodies are sitting here at the usual 98.6 degrees. We're actually warming up the air around us, and that warm air rises up towards the ceiling where we have vents that's pulling that warm air and passing it over the cold water that would be going into the exhibit. And so the countercurrent heat exchange actually helps us save energy warming up the water to go into the open sea. Because while most of the exhibits, it's all ambient temperature from the Monterey Bay, the open sea exhibit is usually right around 70-ish degrees in there. As Trooper is making a nest behind
Trooper knows a little bit about countercurrent heat exchange, and she wishes she had some of those endothermic properties added to her right now. Looking for a little warm spot to hang out. Awesome. Cool. Well, so I'm looking at the time. It's 12:25. We can keep going. I want to keep nerding out forever, because I just learned about omnivorous sharks, and I'm pretty jazzed about that generally.
Omnivorous sharks and eye teeth.
Yeah.
So we're having a great day.
No, there's definitely a nap happening after this just to process. I feel like there's a lot going on there. But usually around this point, we can keep going as long as you feel like. But usually around this point is when we go through a little bit of rapid fire questions, make sure that we get to all of the fast stuff. So if y'all are ready, Jada and Amani, Emily, let's hit them with some rapid fire audience questions there. What do the folks want to know?
I've been saving some of these for right now. All right. For both of you, what is your favorite shark?
Great hammerhead.
Pressure shark.
Easy one.
There was no hesitation. Here, Amani, I'll go to you super quick. Why the gray hammerhead?
Well, so we already talked about them, and all of the things that we listed about them is why they're the coolest shark ever. I just love them because of their heads, and I think it's crazy that they're so dedicated to eating rays that they are okay getting hurt.
Awesome. Jada, explain yourself.
Yeah, so I love thresher sharks for the opposite reason. She loves them for their head, but I love threshers for their tail. It makes up like 50% of their body length, and they use it as a whip. So instead of hunting with their face, they hunt with their tail, and they whip their prey, and whatever's stunned or killed and isn't moving, they just like can slowly go through and collect all those little dead fish. And that's how they hunt. And I'm like, that's so cool. That's way better than like chasing everything down and being super unsuccessful like the great white shark. A little bit of shade there.
Oh, hey, hold on. We've
There's
had
fighting words.
we won't have that kind of stuff. Nah, it's fine. Yeah, totally.
Respect for the great white shark, because the white shark is awesome, but the thresher shark's cooler.
The
Sorry.
thresher sharks also look shocked all the time.
They
They
do.
look so surprised.
Their face is literally just like,
Wait, hold on, Amani. I didn't have you. Okay, so Jada, we got that impression. Amani, what was that again?
oh, they go like this. If you look up pictures, they look like they've just heard the most shocking news of their life. All the
They,
No
time.
way.
they look like they just heard that whale sharks have teeth for eyes.
Oh, whoa. The bonnet head does what? That's hilarious. Awesome. All right, Emily, next question.
This is another great one here. How can people tell what kind of sharks are near where they live?
You can get a field guide.
Yeah, that would be my first thought.
Yeah, field guides are super helpful. They just kind of have like pictures and descriptions of what animals are in an area, and a little bit of information like maybe how deep they live or if they come close to beaches or whatever else, things like that. Field guides are super helpful and I love them. And they usually have scientific names so you can confuse your friends.
Nice. Do you have a favorite scientific name for a shark?
Oh, yes. Sphyrna tiburo is the bonnethead shark, and tiburon in Spanish means shark.
Nice.
And I think that's cool.
Sweet.
I'm gonna have to go with the nurse shark because it's glingly. Wait, hold on. I can never say this. I'll try again. I googled it to make sure I can pronounce it correctly. It's Gingly-mastoma serratum, and gingly just makes me laugh.
Just, Gingly seems like a dwarf that was not invited into the Fellowship of the Ring. It's like, and my oh, okay, never mind.
Oh, or I really like the zebra shark, which is Stegostoma fasciatus. And I Stegostoma, just it sounds like a dinosaur. And I think
Like
that's really cool.
Stegosaurus. I love it.
That's awesome. Cool.
All right. Biggest shark, smallest shark.
Smallest shark is the dwarf lantern shark. It is the size of a human hand. It's tiny, and also it has bioluminescence, which is dope, and it lives in the bottom of the ocean.
Hold on.
Yeah.
Explain that a little bit more. Bioluminescence, what's going on?
Yeah, so different sharks have this, mostly deep sea sharks. Basically, it's the ability to produce a little bit of light around your body. And for most sharks, it's, I think from what I've read, it's attract prey for them,
Okay.
so that they can get some food. But the dwarf lantern shark is super cute, and you should look it up. And it's so small. And Jada can be the largest shark.
Yes, the largest shark is the whale shark, which is also the largest fish in the world. And I think that is proof that cartilaginous fish are the best fish. But yeah, they have teeth for eyes, basically, like a layer on their eyeball. And they are filter feeders. And I think that it's really cool that the largest animals on the planet are filter feeders. I don't really understand how that works. And I think that the funniest thing that I can think of is they are the most, I guess you could say, murderous shark because of the millions and billions of plankton that they kill to eat all the time. And I just think it's so funny. Yeah, they're strong.
that really puts a soup into perspective.
Yeah.
Wow. Okay. That's
All
awesome.
right.
Oh, wait. I just had a quick follow-up question related to the whale shark. Sorry, this is breaking a little bit of the rules of the thing. How did you two feel as shark scientists that in Finding Dory, the whale shark spoke whale when they are... Did that bristle? Were you just like, there's probably a foreign exchange event? Like, was there anything... Like, how did we feel?
I didn't love it, but I'm honestly more irritated about the fact that they threw fish into her exhibit when she is a filter feeder. That's not how that works.
Yes.
Yep.
I am, okay, you guys are going to hate me for this, but I am even more annoyed because clownfish actually change genders when they need to.
Yes.
So technically, when the mom died, Marlin should have become a female, but he didn't.
And he also never, it just, I made an entire PowerPoint It was entitled "Why
Everything wrong.
Disney Doesn't Believe in Biology," and it was all these little biological mistakes in their movies. And my friends were like, "Why do you ruin every one of my childhood favorites?" I'm like, "Because I have to."
And we just want to say, you know, to the Pixar folks out there, thank you so much for featuring these organisms. But it is something that is. But no, we talk about that a lot, about how Nemo was a boy because they all start off as males. They actually start off as nulls, and depending on if they land on the anemone fish, we've talked about that before. But Marlin should have literally become Nemo's mom eventually, and then Nemo would have eventually transitioned into being Nema or whatever it would end up being if Nemo ended up on their own anemone there. Yes, so sequential hermaphroditism. The scientists are gonna. They're going to note you on that if you include those animals. Awesome.
I will say, though, those are some of my favorite movies. So, like,
100%.
I'm not shading Disney or Pixar at all.
You.
It's a great movie.
I will watch that any day.
Absolutely. Thank you to Pixar. But we definitely, and like just the tropical fish going into the kelp forest and they're not thermally shocked and like no issues. Anyway, okay, moving on. Emily, more rapid fire.
That'll be the next live stream that we do. Monterey Bay Aquarium discusses why Finding Nemo needs to be remade. So this is going to be our last rapid fire question for you all. Are there freshwater sharks?
Ooh.
There are sharks that go into freshwater.
Okay.
There's everyone's favorite example is the bull shark. They can go into freshwater, and I believe one in the 1900s, don't know what year, but was actually found so far north. They found it up the Mississippi River in Illinois, and that's crazy. Yeah,
it heard of deep dish and was just like, I gotta go check it out.
Exactly.
They thought it said deep fish pizza.
Right, deep fish pizza, and then no, it turned out. Oh, sorry. That's terrible.
Yeah. There are freshwater rays, though.
Oh. Where at?
So there's like the Xingu River ray, I believe is in the Amazon. There's the Seha River ray. I'm not exactly sure where that one's located. I wouldn't be surprised if it's in the Amazon, but there are freshwater rays, which I think is really awesome.
Oh, wow. Cool. Amani, did you have something you wanted to add to that?
I was just going to say that like the ability to go from saltwater to freshwater is super cool because that's all in salt regulation in the body. And if I'm remembering correctly, I believe that bull sharks actually have a something that aids with their salt retention located near their tail.
Whoa.
Yeah, I believe they have special glands and they're located towards their tail and that help them basically regulate how salty they are, which is what allows them to go into fresh water without essentially like drying out.
Whoa. That's great. That amazing. Just so many, like you wouldn't think like, oh yeah, we're just gonna find out about like bull sharks have salt shakers in their tail, like ready to go to help adjust their internal seasoning. I like the idea of internal seasoning for osmoregulation going forward. I'm just gonna be like, they have to adjust their internal. That's fascinating. Well, we've learned so much and I can't believe it's been an hour already nerding out with the sharks. Let's see if I'll just put both cam. Well, no, we'll just stay right here with the open sea cam they're running on the side. Just want to say thank you so much to you both for being there. Thank you to the audience for all the questions. This is a stream that we're doing ahead of next week, which is Elasmo Week. #Elasmo Week over on Twitter. So if everybody over there can head over, there you go. And if you've got some shark hats, shark shirts, Jada has a sharka going right now on the shirt. Yes, respect the fin. So cool. So next week is going to be all about talking to different shark scientists about their research, about their work. So go over, follow at Elasmo Week over on Twitter, #Elasmo Week as well. And before we head out, I did want to ask both of you about Minorities in Shark Science, which is at Miss and then _Elasmo over on Twitter as well. Can you tell us a little bit about where that came from and what the mission is there of Minorities in Shark Science?
Yeah, totally. So I'm going to briefly talk about Elasmo Week because we're actually going to stream it on our YouTube channel, on the Minorities in Shark Science's YouTube channel. So if you want to watch that, you can subscribe, and that is how you can see all of the cool, amazing scientists that we have going next week. So that's just all the viewers know where they can find
Link is in the description. Make sure to smash those bells, smash the like button, ring the bells, hit that subscribe button. Yeah.
Yes. So how Minorities in Shark Sciences was created. Basically, there was Blackbirders Week back in July. And the four of us, the co-founders of MISS, basically had all been feeling lonely in shark science. We were like, we don't know really any other women of color, specifically Black women in shark science. And we kind of found each other through Blackbirders Week. A couple of us knew each other from like a phone call here and there. But none of us have ever actually met in person. We have only met over Zoom calls and in creating this organization. So we essentially decided to make it because we wanted to create a community for women of color in shark science, to give them a space where they could feel safe, to give them people who are already in shark science that they can talk to and reach out to. And we've just been having a ton of fun with it. And we love showing off our members. We have a membership page on our website, which is misselasmo.com. And you can see we have like over 110 members at this point. And you can see all these amazing women of color that are interested in shark science.
Yes. And my favorite thing, something that we love to say, and like my favorite thing to say ever, is that diversity in people and ways of life and mindsets creates diversity in thought. And diversity in thought is exactly what we need for science to succeed. So we need everybody for science to be as amazing as it possibly can be. So being inclusive is incredibly important in every aspect of life, and especially in science. We need everyone. This should be a space that is welcoming to everyone, and we want to make it feel that way. We don't want anyone else to be like, oh, I'm the only one in the room, or I can't talk to this person. We want to make sure that everyone has someone to go to, has a community. So we just want it to be as inclusive as possible because it's helpful for people and it's helpful for science.
Excellent. And I don't know, Emily, we usually have final questions for the two of you related to the folks that are out there watching right now who might be inspired by your passion for sharks, your passion for the ocean, and being able to just nerd out freely over how cool these animals are. So Emily, hit us with those parting questions.
Yeah, are so many people online right now who are just incredibly inspired. Your enthusiasm is absolutely infectious. You can tell that from everything that we talked about today. I know that Pat and I are already stoked to go learn some new things about sharks. But for everyone who is tuning in right now, young and old, what advice would you have for them if they are interested in getting into shark science? And how did you specifically get into shark science?
I'll go first. Yeah. I watched a lot of documentaries as a kid, and I also lived in landlocked states. So the fact that the ocean was an ecosystem that I didn't have access to and that I couldn't, just go observe on my own time just made me want to know more about it. So I watched a lot of documentaries, and the more I learned about sharks, I was like, they're not these evil things that people have always told me that they are. They're just, dogs that live in the ocean, basically. So I was like, they deserve to be respected. They deserve to have someone rooting for them. So I was like, all right, I'll be one of those people to root for them. I want to help them. I want to make sure that they're doing well and that they're being respected and that their space is being respected. So that's how I got into shark science. But my advice to you is, doesn't matter if you're super young, super old, halfway through college, in a landlocked state, like in the Midwest is where I grew up, and then in the desert. It doesn't matter where you are or who you are. If you want to do it, you can make it happen. You just have to try, and you can make it happen. Because if you want it bad enough, you're going to get it.
That's awesome.
Yes. So I got into shark science kind of later. I grew up in the San Francisco Bay Area, so I grew up going to the Monterey Bay Aquarium, which was my first interaction, I would say, with sharks. And I have the kelp forest ingrained in my mind at this point. Always been interested in sharks. I just never thought it was something that I would go into necessarily. I didn't have all these opportunities thrown at me or anything like that to get into shark science. I applied for a scholarship with Field School, which is who I'm working with now, as doing a fellowship with them, to go do their shark course for a week. And I basically just that I loved being on a boat. I loved handling sharks. I loved being near them. Just like the joy of doing all of that was something that I hadn't experienced with other jobs. So that's essentially how I got into shark science at this point. My go-to advice for people is to take literally any experience that's thrown at you, even if it doesn't have to do with the field you want to go into. I worked in a paleoceanography lab for my 4 years as an undergrad that had nothing to do with sharks whatsoever, but it was experience, and I learned a lot about lab organization, about hitting deadlines. Like getting as much experience as possible is incredibly important. And when an opportunity is given to you, you should absolutely take it, because even if that person's not in your field, they'll still write you a reference letter if you do a great job with them. And having people that will have your back and say, this person is a really great person to work with. This person will learn. This person will be their best for you. It's incredibly important. And you can start doing that at any age, and just build up basically like a network of people who will support you.
Absolutely. Oh, great advice. Thank you so much for sharing. I'm so excited for everything that you're going to help us learn about sharks and the ocean in all of your research there. And I know that the audience there is very excited to learn all about the ocean that you're doing, and to hopefully join you in those ranks here very soon. Well, I think that pretty much is going to do us for today. We should plan another one very soon. But again, the things that we need to plug are next week, September 6th through September 16th, is the first #Elasmo week. So make sure to follow that on Twitter so that you can learn more about shark science from a diversity of shark scientists out there. It's going to be so cool. So who you want to follow over there is at Elasmo Week over on Twitter. And then Amani over on this side of the screen is at @curly_biologist. And then over here, Jada is sophistication. Love that pun. It's an awesome name. All those links are in the description over on YouTube if you want to follow those there. And with that, and follow at Miss_Elasmo over on Twitter as well. And then make sure to check out their YouTube channel. They just launched it. Get those subscribers up there. There's going to be a whole lot of cool features over there. All right. Well, with that, everyone, thank you so much for tuning in for some shark watching with some shark scientists. Thank you so much, Jada. Thank you, Amani. Thank you, Emily. A huge shout out to Curtis, who's over here as well. Thank you, Curtis, for flying those cams around. If you enjoy any of the webcams that the Monterey Bay Aquarium has to offer, that's Curtis right over here. Thank you so much, Curtis, for all of your amazing work there on the cams. Thanks so much, everyone. Hope you have a jawsome rest of your day. I hope this was finteresting, and we will see you again soon. Thanks, everybody.
Thanks, everyone. Bye.
Thank you.